This is the video for Algebra 1 Summer School, Unit 2, Topic 3, Solving for Y and Graphing Lines. In our notes, we talked about how that we always want to graph a line once it's put into slope-intercept form. Y equals mx plus b. M represents the slope. B represents the y-intercept. When I look at the examples on this practice, my equations are not in that format. They're not y equals. So I end up having to solve an equation to get y by itself. So what I'm going to do is I'm going to draw my line down under equals to keep organized. And I'm going to move the term with the x first so that I get y all alone on the left. When I subtract 2x, I end up being left with 7y equals 14 minus 2x. Now I'm one step closer to getting y by itself. I now divide both sides by 7. That undoes the 7 times y. And divide every single term in the expression by 7. That leaves me with y by itself equals 14 divided by 7 is 2 minus the fraction 2 over 7x. That ends up being your final answer. So when I look at this problem, the negative 2 over 7, the number in front of x is my slope, and the number by itself, 2, is the y-intercept. I graph as I have been for the last few lessons. This y-intercept of 2 is my starting point. I start there on the y-axis, then I follow my slope. Negative 2 this time means I go down 2, right 7. That's the slope. It doesn't look like I can go any farther on the right, so I end up going backwards the other way, up 2, left 7. And you can only fit 3 points on this graph. And then I can go ahead and take my line maker here, connect those points. Oh, that was a really bad job on my part. And then make a nice little line. All right, that line's not too great, but yours will be better. Right? Now let's look at number 6. Number 6 is y minus 5 equals 2 times x plus 1. In our notes, we had a problem similar to this. When we're solving equations, we do not want there to be parentheses. So the very first thing you have to do is distribute the 2 to both terms inside the parentheses. Once I do that, I end up with y minus 5 equals 2x plus 2. Now it makes it a lot easier to solve this equation for y. All I have to do is do the inverse of subtracting, which is adding 5, which gives me y equals 2x plus 7. I can only add the 5 to the 2 right here because 5 and 2 are like terms. That's my final answer. So now I can fill in the slope. This number in front of x is 2, and the y-intercept is 7. So I go up to the y-intercept of 7 here, and I have a positive slope of positive 2 over rise over 1. I do the same in the opposite direction to make my graph have a positive slope. And then I'll use my straight edge to connect those dots. Right? And there you go. There's the graph. Y equals 2x plus 7. All right, last problem here, number 8. X plus y over 3 equals 2. Same as the other problems, I want to move what has an x first so I can deal with y. So I'm going to start by moving x minus x from both sides. That's going to give me y over 3 equals 2 minus x. I cannot combine 2 minus x because they are not like terms. Now, in order to get the y by itself, this is similar to a problem on the notes. I need to multiply both sides by 3. When I multiply both sides of an expression, every single term gets multiplied by 3. It's just like when I divide. So when I do that, I end up with y equals 2 times 3 is 6 minus 3 times x. That's your final answer, giving me a slope here of -3 and a y-intercept of 6. Plotting those on my graph, the starting point, the y-intercept is at 6, and my slope is negative, meaning I'm going to go down 3, right 1. I'm going to go down 3, right 1 a few times until I've run out of room on my graph in either direction. Graphing that line should go right through all of those points. If you have questions on any of the other solve for y and graph problems that I didn't do, I did 3, 6, and 8, go back to Canvas, look at the answer key for the practice, and if that isn't enough to help you, come into office hours and speak with your instructor.